If you want your character or mesh to move and bend, the best way to do this is with an armature modifier and vertex group weights. This is how you tell the software which bone or bones you want each vertex to follow along with at what percentage or weight. And to be able to do this successfully, you will need to know about weight painting, which is also called skinning or binding. In this video, I'll give you the main overview of weight painting with a few tricks, etc. But in the next lesson, we'll focus on the tools and the settings in a bit of a demonstration. But first, the weight painting overview. To actually get an armature to bend and deform your mesh, you actually need a few things. The first thing you need, obviously, is an armature with some bones in it, and these bones need to have the deform option enabled. The next thing you need is a mesh, as well as the armature modifier. And then with our armature modifier, it can either use the vertex groups or the bone envelopes, or both if you wish. But bone envelopes aren't that flexible, so they're not really a solution that we want to use. And we also need some vertex groups that match the names of our deformation bones. So these are 3 groups that are actually going to deform the mesh. And then we have an extra group down here, which is used for, say, a particle group or something like that. Now, I've already weight painted this, so if I scrub my animation, you'll see that it is bending our mesh here. And do not worry, we're going to go into more detail on that in a moment. First, let's have a look more into this tabs over here. So you've got some buttons here to add extra groups if you want, and then you can click on them and give them a name. You can just click on any of these and change the name. Now that I've broken that name, you'll notice that it doesn't deform anymore. So these names need to match the names of our bones. You can delete any group with this button here. And you also have lots more functions down in this drop-down menu here. I'll let you go through them on your own. They're all pretty self-explanatory. You can reorder the groups with these buttons here. And you can also drag this bigger, and if you've got a lot of groups, you can also do a search. That's often very handy when you have hundreds of groups. So now I'm going to jump into edit mode and just talk about the information that you can see about each vert inside that item tab up here. So at the bottom of the item tab, you can see this vertex group panel pop up. If we don't have anything selected, it won't be there. If you have more than one selected, it's actually showing you the information about the active vert, which is the one that is highlighted in white. So we have 3 tabs here. The All tab will show you all of the groups that it is a member of. The Deform tab will show you all of the deform groups that it is a member of. And the other will show you all the non-deforming groups. So at the moment it's not part of one. I'll just select that. And I'm going to add it to this group here. Don't worry, we'll go over this in a moment. But I'm going to assign all of these to our particle group. And now you'll see it show up here. You can see that under the other, it won't be visible in the deform. And here in the all, you can see all of our groups. You can also click on these and it will update what you have selected over here. Any of these clipboard buttons here will copy the weight of that group from the active vertex to the same group on the selected vertices, but that's just going to do the single group, whereas this button down here will do all of the groups that you have displayed. In our case, that will be all because that's what we've chosen here. And the little X will remove the active vertex from the group. However, this is only going to do that active vertex. It won't actually do the selected vertices as well. And the normalize button will normalize what we have showing here so that the values add up to 1. So if I actually click normalize, it's going to normalize all of those values. But we usually don't want to normalize a non-deforming group, which would be our particle group here, because not only will you mess up our bone weights, but we'll also mess up the weights of our particle group. So I'll just undo that. We often find ourselves needing to normalize just our deformation bones. That is only one way to normalize the weights. I'll go through some others later after we talk about some automatic weighting. Now I know you've already seen some of this, but it's always worth showing it again. But to connect this mesh here to our armature, we can use the parenting menu. So I'll select the mesh, then the armature and hit Control P. And the 2 automatic options are using envelope weights and automatic weights. Now this one here isn't actually going to use envelope weights. It's going to turn those envelopes into a vertex group, whereas the automatic weights is going to use Blender's internal algorithm to try and weight the mesh based on the flow of the geometry and the actual bones that it wants to weight it to. So that's what I'm going to choose here. And you'll notice it's jumped over there. That is because my armature isn't at 0, 0, 0, which I do not recommend. So I'll just clear that inverse. Now let's have a look. So you can see that the automatic weighting on this mesh hasn't done a very good job. And part of that reason is because it wasn't at 0, 0, 0. But often you'll find that some shapes just work better than others. And most of the time, actually, automatic weights is a great starting point. However, in this situation, it didn't do very well. Okay, let's have a look at our mesh now. So I'm just going to shift select our armature, then our mesh, and then jump into weight paint mode on our mesh here. And you'll see we have some options up here. And because I have the armature selected as well, I can then just select the bones. And you can also select your bone groups from up here. I will go through more of those options in the next video, but what we're looking at here are the weights that were added automatically. Now, most people think that that is the only way that you can add your automatic weights. You have to do it all at once when you parent the actual mesh to the armature, but that is not the case. You can do it on a bone for bone basis. Up here in the weights menu, we have these options up here: assign automatic from bones and assign from bone envelopes. I'll just use the envelope weights now. You see it's taken that envelope and turned it into a group. Let's use the envelope weights for that one, and let's use the envelope weights for that one. So by choosing these options here, you're only doing it on what you have selected, and you're not going to wipe out any of the weight painting that you may have done on the other bones. You can choose automatic or envelope weights on whichever single bone that you want. Or in case you're wondering, I chose envelope weights in that situation because automatic weights was doing a poor job. But most of the time, it's the other way around. Sometimes the automatic weighting can totally fail. You'll get a warning that says bone heat failed to find solution for one or more bones. Now this usually happens because the vertices are too close together in world space and there's too many bones kind of overlapping for it to figure out a proper solution. The easiest way of fixing this is to scale your armature 10 or 20 times bigger, running the operation again, and then reverting your scale back to what it should be. And that should solve your problem. Now let's have a look at how you assign weights using the vertex group tab over here. So this mesh already has the armature modifier connected to it, but as you saw, there are no vertex groups. We are going to fix that. I'm just going to add 3 groups now and make sure they match the names of our bones. And then I'm going to jump into edit mode, where you can see this extra information pop up at the bottom. I am just going to go to wireframe. I'm going to select all of these verts, and then I can choose the weight. This will be a weight of 0. That's a weight of 1. My active group up here is bone 1. And if I hit assign, jump over into weight paint mode, you'll see weights have now been applied. I'll explain what the colors mean in a moment, but let's just jump back into the other bones. Select the middle section, assign them 100% to the middle. Let's just select these. Now you can set whatever weight that you want. So say if I want only one of these verts to be 50%, then that is the weight that they will get. I can also remove the selected verts from a group by selecting them and then making sure I have the active group. So I want to remove these from group 2. I just click remove. That is not connected to the weight there. That's going to remove them from the group. There's also a select and deselect buttons here. Obviously the select will select all of the vertices that are a member of the active group, and the deselect will do the opposite. Just bear in mind that a vertex can have a 0 weight and be a member of that group. That's just something to be aware of in case it's selecting your 0 weights and you're not sure why. So let's have a look at what the colors mean and all the things to do with the overlays of our weight painting. So first, I don't have the ability to select my bone groups up here. However, if I select the armature and then our mesh, you can see we have an extra tab up here for bone selection, and then I can select my bones. So when we're weight painting, that is a really handy option. Okay, so what do the colors mean? The red color is a weight of 1, and that is a gradient all the way down to blue, which is 0. But that is the default display behavior. If you jump up in here to the weight paint overlays, you have this 0 weights option. And I think it's better to turn this over to active. That way, if a vertex is not a member of the active group, it's going to show up as black. Whereas if it is a member, but it just has a 0 weight, then it's going to show up as blue. This makes it a lot easier to spot any weight painting errors where you may have accidentally painted some really low weights somewhere on your mesh where you didn't mean to. There are some other options up here in that overlay menu. The weight contour is an interesting one. I don't really use it that often, but it can be helpful to see how the weights flow together. I only really find it useful if you know, oh hey, this bit is meant to be straight, but then you can see that there's a little bit of a crooked arc or something like that. It's not an option I use all that often. And this show wire option here, I don't think this works well in weight paint mode, so I don't use this one at all. I find it more useful to go over to the main overlays and then turn on the wireframe for the geometry instead. But seeing the wireframe is super helpful because you know where the vertices are that you're actually painting these weights onto. So that's all of the overlays that I want to explain about weight painting. Let's jump into this crazy thing called normalization. So what is this normalization thing that I've mentioned a few times now? Well, I think about it as the true values of what our vertices will be doing. Here I've got a monkey head that is connected to this 4-bone armature. And if I have a look at the weights here, you can see that each bone is actually weighted 100%. Now you might think that if I move any one of our bones, it's going to move 100%, but you'll notice it kind of doesn't, even though the weights tell me that it should move 100%. The issue here is that this view isn't normalized. Blender will always normalize the vertex weights before it does any deformation. I'll jump over into edit mode to have a look at those vertex weights. You can actually see that we have a value of 1.0 for each of these 4 groups. And this is technically not the true weights. I would need to normalize them, and that should drop it down to 0.25 or 25% for each. Of course, that button only applies the change to the active vertex, so I would need to click the copy button to apply that to the rest of the selected verts as well. So let's check our colors again, and you can see that our visual feedback is this teal color, or 25%. This is correct visual feedback. Now, hopefully you noticed that it didn't change the way it actually deforms the mesh, because technically we didn't change or adjust any of the weights. We only corrected that visual feedback. Let me jump back a few steps and show you another way to normalize your weights. So when we're in weight paint mode, we have a few more options up here. We have normalize all and normalize. Now they're going to do very similar things, but this one here without the extra information on the end is only going to do one group, whereas the normalize all can do more than that. And that's the way I remember the difference. Normalize with nothing after it is only going to do one. Normalize with the extra bits can do extra. And this is the one that I want to choose. However, by default, the out-of-the-box settings aren't going to be exactly what we want, because when that setting is enabled, it will lock the active group. And at the moment, all the verts are set to 1.0. So effectively, it will normalize all the other groups down to 0 and wipe them out. And that is definitely not what we want to do. We want to disable that lock so that it is also going to change the active group. But we also have some options in here. We have the selected pose bone, which is only going to do that one bone. We can do all groups, which is something that we don't want to do. So that we had a vertex group that controlled the particle system, then it would also affect that. We always want to confine it to only the bones that have the deformation option enabled. That is our deform pose bones. So that normalize all function is another way to normalize your weights. And that's probably the fastest and the safest way of getting things back in sync with normalization. And here's the last thing that I want to explain in this video. Say in this example, I want this mesh to only follow along with, say, 10% of the movement of this bone here. You would think that we can just jump into edit mode, select them all, assign it to bone group 1 at 10%, click assign, and then you would think that it would only move 10%. But what's happening is it's moving 100%. Now, why is that? That is because of normalization. It's going to take the current group, which is 0.1, over the sum of all the groups, which is 0.1, and that is going to equal a weight of 1. If we did only want it to follow along 10%, you can think about it as needing another group to pin it in place. So I will do a similar thing, jump into edit mode, I'll weight it 90% to the other bone, assign. Now it's only going to move 10%, and it should move 90% with this one. That is one thing you need to remember about normalization. Hopefully all this normalization talk hasn't just confused you, but if it has, here's a really simple way of thinking about it. When you weight paint for deformation, you always want to make sure that your values are normalized, because that is the true value that Blender is going to use. When those weights are normalized, what you see is what you're going to get. If those weights aren't normalized, they're lying to you. Now, hopefully that makes better sense, but don't worry too much if it doesn't, because all of this becomes second nature pretty quickly. I'll see you in the next video.